Since we're not sure, I'll just pick up with this one, solving logs. It says solve for t using logarithms of base a. We'll just go through it real quick. It's a good way to review a few things. Anyway, exponential functions have their variables in the exponents. This is the base, so it's the base of my log. This 3 has to leave before you can do anything. Remember, we want it of the form b equals a to the x. We do not want a coefficient right here before we rewrite it. The coefficient has to be gone. So, I'll divide by 3 first. A to the 4t equals 10/3. And now that I have that, I can rewrite it as a log. Does anyone remember what the word logarithm stands for? Logical arithmetic. Okay? So it's logical that the exponent would equal a log of the same base of the expression. Now we have that. Now I've used divide by 4. Hopefully you've learned enough now that you know dividing by 4 is the same thing as multiplying both sides by 1/4. The reason is you don't like to have denominators with logs. Fractions are what you want. Very, very prominent in calculus. You have fractional logs. So 1/4 and the 4 go away. So t equals 1/4 log base a of 10/3. Okay? So we're in good shape. Quick review on how it works with logs. Remember, the logarithm has the base of your exponent of the expression equaling the exponent. All right? Nice one to get going with. Yep, what is it? Well, we aren't using the calculators yet. All right. So we just said that before we can solve for t using logarithms, it has to look like this. It has to look like b equals a to the x. Okay? In other words, you can't have any coefficients here, and you can't be adding or subtracting anything here. So, a couple things have to leave. First of all, the p or the m, which one do you want to get rid of first? All right, so you can add to both sides. L plus p equals m a to the t over n. What has to leave next? The m, so you're going to divide both sides by m. Now, in my definition, I have L plus P over M equals A to the T over N. This whole thing right here is considered one number. So it follows the rule of B equals A to the X. The T over the N, that's what the X is. The B is one number written a fancy way, L plus P over M. It's just a fancy number. And my base is still A. Now I can rewrite it with logarithms. I can rewrite it using the rules for the inverses and things like that. T over N equals log base A, L plus P over M. The T, actually. I believe the direction said solve for T. Yeah, then you multiply both sides by N and then you're done. Nice. T equals N log base A, L plus P over M. No denominators. Any fractions, any coefficients out in front of the logarithm. Not underneath, not behind. Okay? That'll lead to confusion later on in calculus. All right. We want no confusion because it's already confusing enough. This is pretty good getting back in the swing of things. What is it when it has log by itself? What's the base? 10. So here we go. We know that's a 10 because it has a log. You have a log button on your calculator. It's base 10. So I'm going to write 10 to negative 8 equals x. That's how it works. Great. Yeah, we're in good shape. All right, let's U. What's the base if it has L in? Close. You what? Look, you have a calculator? Okay, above the L in is the number E. So that means log base e. So now I can do it just like the first one. E is 7 plus x equals z. Fantastic. Again, using that little rule we had, b80x equals log base a of b equals x. Okay? Actually, it's biconditional. It goes both ways. This is great. I'm ready to hit the button. Anybody else ready? I'm ready. Do you know how to punch this out on your calculator?
When I do things that keeps putting decimals in.
Yeah, you have to go to mode and go to float instead of 3. All right. Do you remember how to type this on your? You only got. Or we can do. We did this. We can do it the college way. We can do it the high school way. The Greek way. The natural log of 6 to the 7th divided by the natural log of 6. The high school way. Log of 6 to the 7th divided by log of 6. Well, either way you want to do it. Bum, 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 bum. I'm going to go Greek natural log of 6 caret 7 divided by natural log of 6. Nice. Of course, you don't have to use the calculators, but I don't know, it's sitting there. Good. Might as well. What did you get for the second one? Log base 3 of 243. What did you get, Miss Suits? Who? Go ahead. Natural log of 3, base 3 of 243. Natural log. Which goes first, the 243 or the 3? The 243. Divided by ln of 3. Why do you do it that way? Well, because I want to. 5. There's other ways of doing that problem, but right now we'll just remember how to do it on the calculator. Okay? So this one's going to be 5, and this one's going to be 7. Okay? Fantastic. Moving on. You ready to move on?
Yeah.
Let's move on. Solve the equation. Hey, what do you think you can do if you have logs of the same base with the expressions? Well, you can't cross them out, but you can set the expressions equal. You remember we had the bases that were the same, and we had exponents with variables in it? We set the exponents equal to each other because they had the same base. If you have logs with the same base, you can set the expressions equal to each other and you can solve. Now also remember, what is the domain of the expression of a logarithm? Oh, ho, ho, ho. A chink in the armor. You might know it? Greater than, close? Real close. It all goes back to this. B equals a to the x. What's the domain? What's the domain of this equation? I'll put a y there. How's that? Does anybody remember the domain? What number can you put in for x? Yeah, you can put in all real numbers. What does a have to be? A has to be greater than 0, and a cannot equal 1. What does y have to be? Positive. So, if I flip this for the inverse, what's the expression have to be? Not greater than or equal to 0, but just greater than 0. So whenever you solve one of these, you always have to double check, is this stay positive? Does this stay positive when you find your answer? So what's x going to equal here? 2x equals negative 3, x equals negative 3 halves. Does that keep both expressions positive? Yes, it does. Woohoo! There we go. It works. It keeps it positive. Nice job. See? Nobody ever knows there.
What did you just write?
Nothing. I wrote x equals negative 3 halves. I am sure.
So, could you find that first?
Yep, exactly. Like on this one, how'd you solve this one? Let's go to Mr. Matha. How'd you solve it? If we crawl inside your head, what are you thinking right now how to solve this? Who? Oh, nice! Did you bring that up? Did he start laughing? I bet he, I bet he liked that. You could. Or you can write an exponential form. If it's in a log, go exponential. If it's in a log, go exponential. What if it's exponential? What do? Go log. There you go. So, I'm going to rewrite it now. How do I rewrite it? William? Good. 2 to the 4th is, so we got 16 plus 5 equals x. X equals 21. So we find it, we solve it, and then what's the third thing we have to do with our solution we just talked about? Check it to make sure the expression stays positive. And does it say positive? Yes, it does. So now we have an answer. Excellent. Sideways teardrop. I like that. I don't know. All right, moving on. Ready?
Falling asleep and
You want to try this one? This one's hard. This is like almost next to impossible. Sure it is.
yeah, trying to get the most out of every day.
We were gonna
I
break
told my
it.
mom that once at her break and she laughed at me.
What'd you say?
Get the most out of it.
Yeah! Why? Does she not want to get the most out of every day?
Apparently not.
Oh, I woke up every day trying to get the most out of it. Chop, chop, let's go. Plans. We got to go. We got to go.
What'd you do for New Year's?
Me?
Yeah.
Nothing.
Nice.
Big plans.
Big plans. How do you rewrite this? What? Yeah, if it's in exponential form, how are you going to rewrite it? Log form. And then you're going to solve it. And then, what does x have to be? What did we say? Yeah, in this case, the x has to be greater than 0, doesn't it? You can't take the natural log of a negative number. So you check to make sure x is greater than 0. That's our template. That's how we do it. Did you do this already? What did you get? Nice. He's almost done. And you haven't even started yet. Come on, let's go. Be a leader and I'll follow her. I bet what I write, you write. Why don't you write and I'll follow what you write? Go ahead. You write slow.
I wrote my name.
Oh, okay. There we go. Start with an L. Log base E of what? William, what is it? Log base E of what? Well, okay, I'm just going to 0.2. No. You weren't listening to the whole thing. I said fractions belong in front, not underneath, and not behind. For the expressions, you can leave it as a decimal. That's fine. So, log base E of 0.2. How you doing? Equals what? Negative ln of x. What is log base E? What button? ln of 0.2 equals negative ln of x. Well, this is a little different. How do you solve that? What do you do when you don't know how to solve something?
Graph it out.
And there are two ways of solving this if you graph it out. One way, for the 15th time, you can either do two equations and see where they intersect. Or you can do one equation and use 0. Woo! ln 0.2 plus ln of x. I'm going to go the 0 route. If you're going to intersect route, go ahead. Y equals, clear, ln of 0.2 plus ln of x. I'm going to go to the standard viewing window, but I got to close this parentheses first. Make sure you close the open parentheses. Second, insert parentheses, zoom 6. See what happens there if I get one. Yes. What is it?
I don't know exactly. Why do they say R?
Mode. We will be in function.
I didn't touch this all break. What happened?
Somebody did.
Jacob.
Could be. There you go. Now you're back in. So there's intersect. Seconds. Calculate. 0. I'm going to guess between 1 and 10 with a guess of 6. Oops. Quit. Go to. Delete.
They're so fast.
5. Okay.
I have one more question.
5 is the answer. Now, can I take the natural log of 5?
Seriously, I'm gonna punch that kid.
There you go.
Thank you.
You're welcome. So, can you take the natural log of 5? Sure, it's positive. There's our answer. Okay? Sorry.
I did the one, the intersecting one.
Oh, then you do natural log of 0.2 negative ln of x. Okay? That's if you want to do intersects. So far, so good? Good. Sketch the graph of this. Well, it's not too difficult. If you look at it this way, natural log of x plus e, the natural log of x graph looks like this. What's the plus e? Which way is it going to move it, left or right? Remember, we have a f of b x minus d plus c. Which one is the e going to affect? Left or right or up and down?
Left or right?
Left or right. Is it a stretch or does it actually move the graph? It moves the graph, and which way does it move it? In this case, it moves it left e units. Remember, e is a number like 2.7 something. So I'm expecting this graph to be, when I'm done moving it, all the way back here somewhere. Okay? So, the vertical asymptote, instead of being at 0, will probably be at negative e. Oh, because usually we have x first in our general form, and then we have that later. So I'll go to the graph, take a look. Y equals natural log of x plus e. Graph. There we go.
Where's the again?
The e, there's two places. One's above the divide, one is above the ln. If you use the ln one, you're going to have to put a 1 with it.
Oh, okay.
If you use the divide, you can just put e by itself. Does anybody know what that is going to be where it crosses right there? That'd be at 1 minus e, so around 1.7 something, I would guess. Second, calculate the value at 1 minus e. I'm hoping it comes out to be 0, don't you? It does. How fancy is that?
So you're talking about something.
Yeah! What'd you say? Yeah, I did, just to make sure it crossed right there. Because normally, it crosses at, what's this point right here? Normally that's 1, 0. So if it goes that way, e, this point is going to be at 1 minus e, comma 0. Yeah. Well, e is around 2.7, so 1 minus 2.7 is negative 1.7. And t total. Pottle. Yeah. I'm going to look that up over break. I'll let you know how it goes. I mean, over my prep period. Oh, this one. Where's the crossing point at? 1, 0. Find a logarithmic function of the form f of x equals log base a of x for the given graph. The heck are you supposed to do with this? I did graph it. It's right there. Well, 8 represents what? X. 3 represents? Very good. 3 equals log base A of 8. How would you solve this? Right, if you're in a log, you're going to go to exponential. A to the third equals 8. So what's A going to be? Very good. So this graph has the equation y equals log base 2 of x. Okay. Does it work if you put in 1 for x and get out 0? Sure, it works. Okay. Fantastic. It is fun. A can never equal 1. So we're in good shape.
Got the most out of that phone.
We did. Oh, look at this.
It's in red.
It says, this is the original problem. What has changed from the graph in red to the graph in blue? Has this changed? No. That means nothing's been actually moved up or down, left or right. Okay? So if I look at, A, f of b, x minus d, sorry, we're not in trig yet, minus d plus c. Since the point 1, 0 is on there, that means nothing has been moved up, down, left, or right. Okay? That's what the 1, 0 tells you. Now, you have a possibility of a stretch. Well, yeah, from 1 it goes to 2, and from 2 it goes to 4. So which number stretches it vertically 2 units? Is it A or is it B? It's A. B is a horizontal stretch and compress. So the answer would be, yeah, and this one would be f of x equals 2 log base A of x. Everything is stretched by a factor of 2. Okay? Remember, you can move things left and right, up and down, stretch them vertically, horizontally, wherever you need to. Moving on. Ready? We should, but I don't have one ready, so we'll do one tomorrow. Change f of x to an exponential function with base e. How do you change y equals 100, 1/2 to the x to a base e? Is that what the problem says? Am I close? Change it. 100, 100 to base e and approximate the decay rate of f. I don't have a clue. Huh? Divide by 100.
Yeah, you do log first and then ln and then.
Log?
You want natural.
What natural log?
Yeah. I want to put the base V on that.
All right, let's, how about this? The number 7.
Okay. We got it, okay.
Fantastic. That's normally written in base 10, right?
Yes.
I mean, when you count, that's in base 10. The number 11 means what in base 10?
Nothing.
It means 1 10 and 1 1. So if you take 10 plus 1, you get 11, right? What do you think that number means in base 2?
22.
No, silly. It means 3. This equals 3 in base 10. Exactly. Every counting system has a way of rewriting it in a new base. All you have to do is take 1/2. It equals e to what power? I'll call it R. Okay?
So what? Go back to the what?
Go back to the 11.
Yeah. What? How do
You didn't even understand how 11 worked. How are you going to understand how it works in base 2?
I understood how 11 works.
No, you didn't. Here's the ones column. Here's the tens column. Here's the hundreds column. There's the thousands column, right?
Right.
Okay, so the number 11 means you have 1 10 and 1 1.
Right.
Fantastic. That has a numerical value of 11. I want to change it to base 2. How many ones are there now?
There's 2.
No, there's 1 1. And there's 1 2. 2 plus 1 equals
3.
Okay.
3. I want to change it to base 5. So 11 and base 5 equals 1 1 and 1 5, so it equals
10.
6. Okay? Fantastic. See,
I got you now. I understand.
you don't know how 0.5 works in base 10 to change it to base e. So you use exponents. 1/2 equals e to what power? See the powers you got to get to? Because our system operates in base 10. When we get to 9, we have 10 digits. When we go to 9, we go to 1 column over, base 10. So 1/2. How do you find out what this equals? 1/2 equals e to what power? So how do you solve it? It's an exponential problem.
ln to the log.
Okay, yeah. So log base e of 1/2 equals r. So what is the natural log of a half?
That would be a negative number.
Okay, what is it?
Negative
Negative what?
0.69.
0.69. What else?
Raise that 1.
693.
1 4.
6914.
693. 1 4. You hit it.
Okay, 693. There we go. So now, all I did was I took a half and I rewrote it with a base of e. Okay? If you punch this on the calculator, you get a half. The question says, now you've done this, what is the decay rate? It's this. It's that decimal. That's the decay rate. Oh, you know that. Sure you do. Quit being such bumps on the log. If I write this, P equals E. Wait a minute. P equals ERT. A equals PERT. What's R stand for? What's this stand for? Rate. Woo! It's all there. You just got to get up and go after it. That's the rate it's talking about. William. Easy. I punched in the natural log of a half. There's the ln right there. ln of a half. R is for the business model. Any number right here is considered.
Before. Like, why did you put R in the problem?
Oh, because it wanted to change this to a base E so I could approximate the growth rate using this type of equation. 1/2 doesn't have an E in it. So I can't read it like I can that equation. So I changed it so you can read it like that equation. So like the interest rate would be negative 0.693. The negative means it's a decay. I think we're about done. The radioactive isotope K as a constant, express T in terms of Q and K. Well, that's easy. You can do that. Yeah, we'll go on.
We just stop working.
Stop working? Oh no, we're here to go. We're here. Look, don't follow the trail. Make your own trail. No, we haven't even finished. Here we go. How do you solve this one? The population, millions, of India is this equation. When will it reach 1.5 billion?
Set 1.5 equal.
Very good. Set 1.5 billion equal to it, except this equation is already in millions. So if this equation is in millions, what am I going to set it equal to? Since it's already in millions. 1.5 is in billions. It says this is in millions.
So we should put equal to 50.
There. 1.5 billion is like 1,500 million. And now you solve. 0.0182t. You divide by 766. Remember, it has to be of this form, b equals a to the x before you solve it. Right now, it's not. Divide 1,500 by 766, and what do you get? 1.95 what? Okay. Now, to invoke the most famous thought bubble of all, how do you solve this? You go from an exponential to a log, you solve it, and your answer up here can be what? It can be anything, can it? Right, there's no restriction on the domain. So how do you solve it? Natural log of 1.95822 equals 0.0182t. Don't be lazy and round this to 2. You're going to get way off when you're working with logs and exponents. Keep as many decimals as you can. In fact, if I was doing this problem on my calculator for college, view, show or hide it, I would take, second quit, clear. I would take 1,500 divided by 766. I get that answer. I would take the natural log of my answer, and I would divide that by 0.0182. I wouldn't round to my final answer. 36.925 years. Okay?
37.
Yep. That's not too far. That's one, mathematically speaking, that is one generation. Mathematically speaking, a generation is considered to be every 30 years. That they took the average age of parents and children, and they decided the average age for the next generation to begin is the age 30. So the answer is 36.925. Okay? Woohoo! I like that. Sure, we should. As soon as we do this one, this is the one that goes right up Michelle's. I haven't got the 5-minute warning yet. Yeah, that was 5.
No, this was over 5 minutes.
Perfect. Time to finish this one up. Compounded continuously means what? Very good. A equals P e to the RT at a rate 0.06. Very good. We'll take the number of years, T, to take an initial deposit. Which one's this? The 6,000. Very good. 6,000. E to go to 25,000. Kind of like the same as the last one. All right. How do you solve it? Yeah. Clear this all off. 25,000. All right, 6,000. Enter. Natural log of that answer divided by 0.06. You're absolutely right. 23.78 years. Nice. This was a lot of fun today. I'm glad you showed up for it. See, you're all worried about, oh, we know how to do that on the calculator. Sure we do.
Oh my god.
It was. I'm not doing this. You can do it. You can do 0 on the calculator. You've done enough of those. It says approximate it. Take it over the other side and use 0.
What number is this to?
I don't know.
That was fun.
Look at that.
13 to 65 odd. Sounds
13 through what?
65 odd.
Sounds fantastic. Glad you're back in the saddle, back in the swing of things.
You got the most out of that day.
We did. That's more than you did in any other class so far.